Hi, I'm Jim Toll. I'm part of the Optoelectronics group, and this is episode 4 of Welcome Home, where we go into the house and we look for optoelectronic applications. So why the weird angle? Because today's application is that smoke detector up on the ceiling. Let's take a closer look. So this is the dual sensor smoke detector. It has two sensing technologies. One is ionization, where it supposedly could sense fast flaming fires more quickly. And then it has a photoelectric sensor, which can sense slow, smoldering, or smoky fires more quickly. Very much exactly like what you might have on the ceiling in any of your houses. We took apart the sensor in the lab. Here is the insides of it. This is your ionization plate, again for sensing flames. And this is the photoelectric sensor, which contains our infrared emitter and photodiode. And you can see they've created walls that won't reflect directly the light from the infrared emitter to the photodetector. I'll zoom in on this. It might be a little jerky. You can see it a little more closely. So the emitter emits light, and here you see they have a mechanical blocking fixture so that the direct light doesn't hit here. And then the walls are partitioned so that, again, light wouldn't reflect off of here and hit the photosensor or photodiode or phototransistor. All we're looking for is an easy ingress of smoke into the chamber, and then once the smoke particles are in this chamber, the light, infrared light, will reflect off of those particles onto the photodetector, and then you will have an alarm that goes off. I'll take a picture of this and we'll talk a little bit more about it. So this is a close-up of the smoke detector. A couple things to point out. It has an infrared emitter. Here it's a 5mm package with the leads bent at 90 degrees, so the emitter is looking sideways. It has a photodiode. And the structure of the housing is such that it's to prevent any emitted light coming out of the infrared emitter from reflecting and irradiating the photodiode directly. So this center structure here blocks light. This housing around the infrared emitter essentially blocks half the light coming out of the infrared emitter. This structure around the photodiode limits the field of view to a very, very, very narrow angle. And in these housings, none of the light coming off the infrared emitter would reflect and hit the photodiode directly. And the walls, of course, of the housing are open so that air and smoke could flow through. So when smoke actually enters the smoke chamber, the light that's emitted will reflect off of the smoke particles and bounce onto the photodiode. That light hitting the photodiode will create a current, which sets off the smoke alarm. Smoke alarms are a critical safety device for anyone living in a house or an apartment. You can imagine that they're extensively tested by safety certification companies like Underwriters Laboratory to make sure they work properly. Now, the Opto Group creates an infrared emitter called the TSAL 6100 UL. It too is UL approved. So it just makes it easier for smoke detector manufacturers to know that when their whole system is going to be UL tested, that even some of the subcomponents are UL certified. The side-looking photodiode, we would recommend the BPV22F for this type of an application. The TSAL 6100 UL and the BPV22F the datasheets can be found on our website at vishay.com/opto. There you'll also see our entire optoelectronics portfolio. And finally, I wanted to thank Gene Velchenko for helping me buy this smoke detector. California didn't sell this dual type sensor smoke detector, so I had to ask Gene to purchase one in Illinois. So thanks